Hello, this is Mike at Gamefromscratch. Welcome to another tutorial series. In this one, we are going to be taking a look at SFML, as you can probably guess by looking at the screen. SFML stands for the Simple Fast Multimedia Library, and in a nutshell, it is a game development library for creating 2D games using C++ or various language bindings. In this tutorial series, we're going to create a simple 2D game over time. I'm going to try and keep each piece bite-sized in the 10 to 15 minute range. Today we're going to start off very simple, but probably the point where most people are lost when dealing with SFML, and that is with project configuration. Now, there are a myriad of different platforms and a myriad of different compilers and IDEs that you can use when working in C++. And I would generally say that Visual C++ is probably the most commonly used. So that's what I'm going to show the configuration for today. So we're going to look at downloading and setting up SFML to create a new project in Visual Studio C++. Now, if there's a lot of demand for other platforms such as Xcode or Code Blocks or others, I can definitely look at covering them. But right now I'm going to focus on Visual C++. So that's exactly what we're going to cover today. As you can see, we've got the webpage up right now. All you need to do to get started, we're going to do this from the precompiled binaries. We're not going to build it from scratch. Again, that is something I can cover if there's enough interest in it. It uses a CMake-based build system, and it's basically a project file generator that you then use with whatever your native tool is. So if there's a lot of interest in covering building SFML from scratch, let me know in the comments, and I can easily cover that in an additional post. But we're going to use the precompiled binaries. Coincidentally, there is a set of these maintained daily builds. So if someone is actually doing builds on a daily basis, you can go ahead and download those as well. So if your particular version isn't supported here, you can get it elsewhere. I'm going to go ahead and use 2013. I know 2015 is out, but 2013 still seems to be probably the most common version. Obviously, if you want 2015, you can grab it here. Now, the next thing to be aware of is 64 and 32-bit are different things, completely incompatible with each other. So know what your tooling is or what kind of a project you're going to create. I'm going to go ahead and grab the 32-bit. Even though I'm running on a 64-bit OS, it's just as easy to build for a 32. And that's mostly just, and with time this is going to go away, but a lot of the Windows XP installs out there are still 32-bit. And you don't, especially for a simple 2D game, you gain very little by going to 64-bit. Beyond having more than 2 gigs of RAM available, addressable, there's not a lot of advantage. So I'll start with the 32-bit version right here. You can see that's already downloaded. Let's go ahead and grab that in my directory here. So SFML, that's right there, or I grabbed it earlier, but we'll go ahead and grab this guy. So we just want to open that up, and here are the contents of it. And we're going to be using portions of this, but not all of it. So here, let me just pin this to my right here. And now I'm going to fire up Visual C++. Okay. So we're going to be creating a new project over here, and then we're ultimately going to be using some of these files in it, and I'll show you which ones in a moment. So just go ahead and create a new project. It is the type Visual C++, and now you can either be a console app or a window app, but we'll go ahead with a console app just as easy from now. We shall call the SFML YouTube, like so. I'm creating everything out of temp right now just because. We'll go ahead and create that. What? Solutions provided. Wow. Alright, I gotta clean up my temp. I'm doing way too much stuff out of there. So just gone ahead and created that file. Now you got a choice between a Windows application or a console application. The difference is going to be if it's a Win main or a normal main. And the tangible difference to you is going to be if there's going to be a console window there or not. I'll actually show you down the road how to switch from having a console window to not having a console window, but for now make it a console application, because when you're developing, it's actually kind of handy to have that console there because we can do redirects to it. So we can do some debugging information out to it, etc. But when you go to deploy, I'll show you how we can actually get rid of that console window. Don't worry, it's very easy to change this setting after the fact in C++ compiler. I also want to start from scratch. We'll go with empty. I don't actually know what that check does, to be honest, so we'll turn it off and generate our project. So this is it. As I said, it's empty, so let's go ahead and add a new CPP file, and we shall call it main.cpp. like so. Okay, so now we have to actually configure this project, and this is where it's going to lose a lot of people. So we're going to hopefully get through this no problem. Let me just make this a little bit more visible. Present on. Okay, so first thing we need to do is set up the include path and the linker. The linker is the thing that links all the existing libraries into your code, and the include path basically says here are additional directories where you can find #include files or header files as it would be. So we're going to go in and set both of those suckers up. So first off, go into properties, and let's start with the header files because there's really nothing special to do that. We just want to go ahead and set additional include directories. Now we set it up to use this folder, but I'm instead going to copy the files we need out of here into our folder. So let me just bring up a new window here. Go command explorer. Okay, so C and SFML YouTube demo. Okay, so there's our project directory, and over here what we want is lib and include. So those are the two folders that we want to bring over. Now there's a bunch of stuff in lib that we don't necessarily need, but it's easy enough just to bring them in. So copy both those in. Okay, now there's one other thing that we're going to want to do, and that is bring in the DLLs, because we're going to be using the dynamic build. I'll explain that in a second, but now we're going to need, when we run our code, we're going to need to have these DLL libraries. That's what they're going to look for. So first let's just go back to our code over here. Let's cancel out and just Control-Shift-B to do a build. Oh, okay, maybe I should make a main. 1 second. Int main int argc char star argv. All right, so we needed an entry point for our code. Okay, so we went ahead and built it now. So if I go back to the directory for our project, we shall now see that we have this debug folder and our executable here. It's not going to do anything, as you can see, but it is there. Now what we need to do is go ahead and bring in these DLLs. We technically only need the debug versions for now and this guy. So any of these -ds, or you can be lazy and bring them all in. What can I say? Hard drive space is cheap these days. Now, if you're going to deploy, though, obviously you're only going to want to deploy the non-debug versions, which is the ones without the -d on the end. But now we have the DLLs in our folder. We're going to need that later on, and if you don't do this step, you're going to have an explosion when you try to run your code. So that's very important and very critical. Okay, so now we've got all the files copied in. We have our include files in the SFML directory of our include folder, like so. And we have our lib folder here. So now what we need to do is configure all this. So back over here, and let's first set up our include paths. So it's right here in C++, so configuration properties, C++, general, additional include directory. And we're going to just drop this arrow down and do edit. Now there's a couple ways you can go about doing this. First, click this little guy to create a new line, and then you can hit here to and you can go to the path you want to do. So you could actually do it like this, and that's perfectly legit. Now the only downside is if you copy this folder to a different location. So if your project is not on the C drive anymore, so for example for D, this will no longer work. So what's often a better way to do it is instead of pathing out like this, we shall instead, let's create a new one, and you can pop this guy down and it'll show you the macros available. And what we want is one called $ either project dir or solution dir. I didn't create a solution dir is where your SLN file is. A project directory is where your, oh, what the hell are C++ projects called? VC something something something. VCX proj file is. Now I didn't create a folder for the solution, so in my world the solution dir and the project dir, as shown here, are the exact same thing. So you can see a preview over here of what that value actually is. But the nice thing is if you use either of these macros, then if you copy the project into somewhere else or you deploy it to somebody else, the path changes for you. So let's just go ahead and use, we'll use project dir just in case we ever throw it into a subfolder somewhere. And now we just need to put in the include path. Like so. I might be making a bit of an error there. I always do on this one. So we can quickly find out if we're right by going pound include, and then we want, yeah, it's not liking that path. Just a sec. Oh, it's because I always do that. I think I have two windows open. All right, it didn't commit. So projector include. So, you know, we'll go with that. We'll add SFML manually. So click off, click apply so you actually get it. Now we go over here. We've got SFML, and then we want to add graphics, like so. So now we've actually included in that code. We'll do a build, see if it grabbed it, and it did. All right, so our include path is now set up just fine. We want to go ahead now and set up our lib path, and this gets a little bit more complicated. Same process. So right-click your project, and instead of C++, we actually want linker. And under general, right here, we want to put the additional libraries path, and this is the same thing, project dir or solution dir, and then I believe I called it lib, like so, and apply and done. All right, so now our lib files are in. I don't know why I closed that, because we're not actually even close to done. Now we actually have to link the lib files in. Now let me show you in the folder quickly what we're dealing with here. And like I said, libs are basically, they're one of two things. They're either a collection of code or a collection of pointers to code. And when I say code, I mean binary code, so object code. So it's basically compiled C or C++ code in a reusable format. Now the two approaches to it are, okay, I guess we're done with this guy, so I'm going to just focus on this folder right here. So this is the lib folder we copied in earlier. These are all the libs used by SFML. And what you can see here is there's a set of double ones, or there's actually, what is that, 4 per, so here's the SFML library, and SFML is built into about 6 different libraries. There's audio, graphics, network, system, and Windows. So I guess that's 5. And each one is kind of independent, except for they all depend on system. So that's important in a second. But each particular library, so here you see audio, there are 4 versions of it. There's SFML audio, which you can see by the size, it's very, very tiny. It's only 54K. And then SFML audio-D, it's also only 54K. And then you've got SFML audio-S, and then -S-D. And you notice the -S versions are much, much larger. And the -D version of the -S is even bigger. All right, so there's a naming convention at work here. The -D stands for debug. That means that each one of those ones has additional debug build information in it. So when you do debug your code, you can get a lot more details about the underlying library. So while you're working on it, like while you're developing your code, you probably want to link to the debug version of SFML. So that's what the -D means. It results in a larger executable for sure, slower code for sure, but a lot more sanity checks, a lot easier to find bugs, and a lot easier to debug information. So that's what the -D versions are. Now the -S, you notice this guy at 1500 bytes, or for 15,000, or 1.5 megabytes, versus this guy at 54K. And the difference there, the -S denotes static. Now when you compile a library or link to a library statically, what you're saying is basically copy all this code into my executable, which is nice because when you're done, your executable will be very, very large because in this case, 1.5 megabyte of code are literally copied into your executable, but you only have one file. You don't have DLL dependency hells, you don't have anything like that. On the other hand, you're having to link in all of your code that you need and all of the dependencies based on it. Whereas if you use this guy or this guy right here, the standard non-static version and the debug non-static version, you're just kind of saying this function exists in this DLL. Now remember earlier, and I'll copy it back, we'll go into the debug folder, when we copied those DLLs in, well that's what the normal version, the non-static version, is just pointing to those DLLs for us. And again, there's a debug version and a standard version. And it all depends. When you're doing a debug release, you would link to the debug version. When you're doing a full release, you would do it to the non-debug version. So there's where we stand. Now what we want to do is go ahead and link in, and I'll get those back up because I'm actually going to want these on screen. So we're going to want to link in all of our dependencies now. And it's an important process. Now, so really all we're doing is we're giving Visual Studio a list of lib files that we're going to go ahead and link to. And that is done in the input directory. And you'll notice here already there's a whole whack of them. This is kernel, etc. Bits and pieces of the OS that we already depend on to run our application. Now, when I said earlier that there was a dependency on SFML system, there's importance to that because you have to do your most dependent to the rightmost. And that'll make sense in a second. I'm just throwing a semicolon. We're going to prefix this entire list. So in theory, SFML system may depend on kernel 32. So it's going to be to the left of kernel 32. While all of our other libs are actually going to depend on system. So they all have to be to the left of system. So let's add in system. And we're going to do the debug version. Oh, I guess I should actually do it right. SFML-system-D. So we're doing the debug DLL version when we link that. And then from now, we're just doing, we're going to need window, so SFML window-d-lib, and then it's a semicolon between entries. And we also need SFML graphics-d.lib. And you know what? I'm not going to want to come back in here and change this later, so SFML audio-d.lib and semicolon. Now, we're not actually going to go ahead and be using network, so I'll leave that out. There will be no networking in this code. These dependencies only need to be defined if you are linking static, so we should be fine there. Otherwise, they should be included in the DLL compiles. So that's that. So click away, like so, and apply. And we should have all of our dependencies set up. So now we're going to have to go ahead and create a very, very simple application just to test to make sure that we've got things done right here. And this is going to be about as simple of a program as we can possibly create. So let's go in, and all we're going to do, and we're going to do a bit of a more complex program coming up. So don't worry too much about that one. So this is a very, very simple, just to prove that our directories and such are configured properly. So you need this include here, because we're going to go ahead and create a window in a second, render window. So let's start by doing that. It's SFML namespace, so if you want to get rid of typing this all the time, you just do using namespace SF, but I'm not going to do that. So we're creating a render window. We will call you render window and call your default, not default, because we're going to give it a size. So SF:video mode 640 by 480. There we go. So all we have done here is created an error. What's your issue? Oh, I guess there's more. Oh, title probably. No, that's all I need. Width, height, and define. I do not know what your issue is. Why are you being so stupid? I think this is just IntelliSense error. I think I need to go ahead and give it a title. Yeah. Damn you, IntelliSense. All right. So, and this is getting kind of confusing. So let me hide all these guys so we got more code room. Okay. So all we're doing here is we're just creating a window, 640 by 480 with the title Hello SFML. We'll probably do a little bit more later on. I'm not even going to bother with an event loop. This game is technically going to be exitable. So all we're going to do is create the window, render window. Oh, I cannot type today. Window.clear and render window.display. So that's all we're doing in this code. See if we got everything configured correctly. And we do. Now, not really exciting because the code immediately exits after, so let's just do a forever loop. All right, seriously, stop fighting with me. I'm not using my normal keyboard and it's killing me. All right. There you go. So all we've got here is a window is created. I told you earlier, we also got this console window in the background, which again can prove quite handy because we can spit out information to it for debugging purposes. But otherwise, we just have this window running in the background, and it's not responding to events or anything, so now I can't even select it. I can't close it. I can't do anything. We can get rid of everything by getting rid of the parent console window. But we'll look at the main loop in a little bit more detail in the next tutorial. So that's not important. I just wanted to make sure that you were up and configured and running properly in SFML. And if you got to that point with that black window and it showed up, everything is working fine. If it doesn't, go back through your linker settings, make sure you didn't do a typo in there. Make sure that your paths are definitely correct. I'll bring them up on screen once more so you can actually compare versus your version. So here are the settings you add on top. So make sure that sfml-system-d.lib is the rightmost of the ones you add, but to the left of kernel 32. And then all of your other ones are added as well. Make sure that you set, let me see, where did you go? Additional lib directory is the lib folder underneath your project dir. Another error that I make way too often is make sure that the $ is on the outside, like so. And the other setting was in C++ under general. Make sure that this include path is in there and correct. And that's about it. Assuming all of those things worked fine, you should be up and going. Now, I'm going to do a text version of this, a very quick, easier version that shows pretty much each of those folders that we just used, how to link in. I'm not going to do a lot of the explanation I did in this video, but I will link it below. So if you need a reference to what we just did, go check Gamefromscratch. There will be a corresponding version there. And then, like I said, we'll go over the various different pieces of making a game over the rest of this series. Now, the focus isn't going to be on performance or anything along those lines. We're just going to look at the process. You can look at optimizing these things later on. We might touch on a little bit of that kind of stuff, but it is certainly not the focus. This is a beginner-focused tutorial, but we will cover some fairly advanced topics, hopefully. So hope that got you up to speed. And again, if you want to learn how to build SFML from scratch, let me know. If you're working in another platform and I have access to it, I can do a tutorial for that as well. So if you're outside of Visual Studio, please let me know. But hopefully that got you up and going, and stay tuned for the next part. Thank you very much. See you then.